Let's use the solve function of the calculator to solve these two equations. The first equation is a quadratic equation. The left-hand side is a quadratic expression, and to solve it on the solver we find the math menu, and solver is right at the bottom of the menu, and we type each side, each expression, the left-hand side and the right-hand side in, and press OK. And here's OK. To access the OK, we press the nearest button there. And what we see, it's generating an equation using expression 1 and expression 2. And what we have here is not the solution, it's the solution of some other equation that I was doing earlier. And so I clear that, and to solve this equation I'll press alpha solve. Again, it tells me that the answer here is x equal 9.77, correct to 3 significant figures. However, if you know about quadratics, you'll know that this shape is a parabola, and it can have perhaps just one solution, or perhaps two solutions, or perhaps no solutions. We talk more about that in topic 6. And so it turns out that this equation has two solutions, so let's press clear and say alpha solve again, but we see it's generating the same solution. So to get more information, I've drawn a graph of these two expressions. The first one is y equal the parabola here, then y equal x. And we see over here we've got the solution which corresponds to 9.77, the one the calculator found for us. The question we have is, what's the value of this solution over here, and how do I find it? In order to use get the solver to find it for us, we need to know something about it. First, we need to know it exists, so we need to know about quadratic equations. And second, we need to know where approximately it is. We can see it's close to 0, so what I'll do is I'll clear the solution and type in 0 as a guess, very similar to finding intersections that we saw in a previous video, that we need a guess to tell the calculator where to start looking. And now I'll press alpha solve, and we get the solution 1.22 or 1.23, correct to 3 significant figures. So that's a drawback of using the solver, is that you need to have some information of the solution that you're looking for when you use it. But if you do have the information, it's a very fast tool. Let's look at the second example we have, number 2. We have an exponential expression here on the left and a constant on the right, and let's type those in to the solver. This example comes from a question which is seen later on in the textbook. And if you have an older version of the calculator, at this stage you need to type in the first expression, subtract the second expression, and that will be equal to 0. Which amounts to the same thing. Okay, again we see the equation generated from the two expressions. The solution was from the question we just did and has got nothing to do with these expressions. So let's clear that, and now I'll press alpha solve. And I get a solution that x is equal to 15.5, correct to 3 significant figures. And my question is, are there more solutions? If there are more solutions, where are they? I could type in 0 as a guess, and it gives me the same solution. What if I type in 100 as a guess? Yeah, again it gives me the same solution. It's helpful to know what you're looking for. So let's have a look at the graph of those two expressions. Here is the graph of the exponential y equal 500 multiplied by 1.1 to x minus 1. Here is a constant y equal 2000. And in topic 6 we learn about the exponential, how it behaves asymptotically and then will either always increase or always decrease. And so we see that it's going to cross a horizontal line once and once only. And there's the number 15.455 blah blah blah. 5458. Okay. So an important thing when you're using the calculator to solve any question in an IB exam is you're expected to show you're working, especially if you're using the calculator. The first thing is we need to write down the equation that you're solving, and you need to write it down with mathematical notation, not with the calculator notation. In fact, you get penalised in some instances for using the calculator notation. So use your own math notation, and then you're going to say solve using GDC. I'm going to say I'm using the solver, starts with an S, and then I'll state what the value x is, and there is my unrounded value of x, and so the examiner knows I got it right even if I goof up the rounding, and there's the answer correct to 3 significant figures. That's the work that's required from you when you're using something like the solver.